lesson 57, which is the combined gas law. I don't know if you guys have encountered it chemistry or physics yet. You may have already done this a little bit, or if you haven't, then you probably get a preview right now. All right, so the combined gas law tells us that T1V1 over T1 equals T2V2 over T2. This is something that you guys just want to memorize. These problems are pretty easy as long as you know the formula. So P is always pressure. V is always volume. And T is always temperature. All right, now something that is useful but not 100% necessary is to remember that if you have something that stays constant, so pressure, volume, or temperature stays constant, you can just completely get rid of that variable from the equation. So what I mean by that is if my problem tells me I have constant temperature, what I can do is just change my equation to P1V1 equals P2V2, and that's it, not even worry about the temperatures. The reason for that is if I were to just plug in the same temperature, they would just cancel out. So like if I had over 2 and over 2, if I multiplied both sides by 2, they would just go away. So we don't even have to put it in there. If you forget to do this and you do put it in there, you'll get the same answer. This just makes solving a little bit easier. Constant pressure, that means our pressures are the same. We're going to have V1 over T1 equals V2 over T2. So we just got rid of the P's. And for constant volume, we just get rid of the V's. We're going to have P1 over T1 equals P2 over, T2. So useful and helpful, but not 100% necessary. If you guys don't remember this, it's not the end of the world. The problems will still work. All right, so we just eliminated the variable that stayed constant. Okay, let's try one. 8 liters of an ideal gas at a temperature of 1,000 kelvins had a pressure of 200 newtons per square meter. If the volume were increased to 10 liters and the temperature reduced to 800 kelvins, what would the pressure be? So really all we have to do is go through these word problems, label what we have, plug into our equation, solve it, and bam, we have our answer. So we always want to start with the equation, P1V1 over T1 equals P2 V2 over T2. We go back through the problem. 8 liters of an ideal gas. Liters is volume. So 8 is going to be our first volume. At a temperature of 1,000 kelvins, kelvins are temperature, so this is going to be our T1. Had a pressure of 200 newtons per square meter, so our 200 is our first pressure. So that's all of our first step. Now what we're doing is we're changing the gas in some way. So the volume is increased to 10 liters, so this is going to be our second volume, V2, and the temperature reduced to 800 kelvins. So this is going to be our second temperature. What would the pressure be? So our second pressure is what we want to know, what it's asking us for. So now all I'm going to do is I'm going to go through and I'm going to plug everything in, and then we're going to solve. So 8 is my first volume. 1,000 is my first temperature. 200 is my first pressure. Equals my second volume is 10 liters. And my second temperature is 800 kelvins. And then I'm going to leave P2 as just P2 because that's what we're solving for. Now, since there's so many zeros in these problems, they're actually pretty easy to solve by hand without a calculator. But you're always, of course, welcome to use a calculator if it's a calculator part of the test. So we're just going to do these ones with calculator. If I want P2 by itself, I can just multiply by the reciprocal. So I'm going to multiply by 800 over 10, multiply by 800 over 10. What that does is it cancels this 10, cancels these 800s, and then I have P2 by itself. So I'd plug into my calculator 800 times 200 times 8 over 10,000, and I will get P2. What'd you get? Yep, there. 128 is what you should get when you plug it in. We always have to go back to the original word problem and figure out what our units are, because they're not always going to be the same. So this time it gave us pressure in newtons per square meter. The abbreviation for that is capital N over m squared. Newtons per meter squared. And this is our final answer. Let's try another. The temperature of a quantity of ideal gas was held constant at 1400 kelvins in an experiment. The original pressure was 11 atmospheres and the original volume was 44 liters. If the volume were reduced to 4.4 liters, what would the final pressure be? So this one, it tells us it's constant. It also tells us that our temperature stays at 1400. So if you forgot that we could just get rid of the t's, we would plug in 1400 for both of our temperatures, and then we would solve. But since I remembered that I don't even need this, I'm just going to do P1 V1 equals P2 V2. If I wanted, I could put over 1400, but that just causes a little bit more complication when you're solving. So I'm just going to avoid that. And we're going to go through and plug stuff in. So the original pressure was 11 atmospheres, so that's going to be my P1. The original volume was 44 liters, so that's going to be my V1. And they changed the volume to 4.4 liters, so that's my second volume. Now I'm going to go back and plug in, so my P1 was 11, my V1 was 44, equals, we're looking for the final pressure, so it stays a variable, and our second volume was 4.4. So I want P2 by itself. We have multiplication right here, so to reverse that, I need to divide by 4.4, divide by 4.4, and I plug in 11 times 44 divided by 4.4. And we are going to get 110 for this one. I'm going to go back and look at what my units were. My first pressure was in atmospheres, and the abbreviation for atmospheres is ATM, so you don't have to write out that whole thing. You won't get it wrong if you write out atmospheres, but ATM is easier. All right, one more example. The temperature of a quantity of ideal gas was held constant in an experiment. The original pressure was 10 atmospheres and the original volume was 42 liters. If the volume was reduced to 10 liters, what was the final pressure? So this one says constant temperature and it doesn't give it to us. If I didn't know, or sorry, if I forgot that I could leave T out, I would just say T1 equals T2, and then when I plug them in, I would either make both my T's T1 or both my T's T2, and then stuff would cancel out. But since I remember I don't need the T's, I'm just going to do P1 V1 equals P2 V2 again. The original pressure was 7 atmospheres, and the original volume was 42 liters. If the volume was reduced to 10 liters, what would the final pressure be? Again, I just have to divide by 10. I'm going to have 7 times 42 divided by 10, which gets me 29.4. We're talking atmospheres, so ATM.